All right, welcome to The Explainer. Today, we're going to tackle a piece of code a lot of you will probably see, the legacy hangman game. And our whole mission here, it's to take this block of code and turn it into an actual engineering blueprint, something you can really use.
Okay, so let's just jump right in. I mean, look at this. When you first see legacy code, it can honestly look like a total mess, right? It's just a wall of text. The person who wrote this, yeah, they didn't leave a single comment. But our job today is to turn this chaos into a clear, understandable blueprint. And this is super important because the number one rule in engineering is simple. You can't safely upgrade something if you don't understand it first. So here's how we're going to do it. We've got a simple 6-part plan. We'll start big picture with the overall blueprint. Then we'll dive into the system's memory, check out the functions that do all the work, and then the main loop that runs the whole show. After we see how it all fits together, we'll get you ready to make your very first upgrade. All right, first up, the engineer's blueprint. Look, to really get a handle on this system, we are not going to go line by line. That's just a recipe for getting lost. Instead, we're going to think like an engineer and map out its architecture. And what you'll see is that it really just boils down to 3 main parts. And here they are. Think of it like this. You've got the system's memory. That's basically where all the information is stored. Then you've got the workers. These are the functions that do all the specific jobs. And finally, you have the conductor. That's the main loop that tells everyone what to do. It's really that simple. Memory, workers, and a conductor. Okay, let's start with that first piece, the system's memory. I mean, every program has to have a way to remember things, right? A place to keep track of what's going on. In our hangman game, it turns out there are really just 2 key places where it stores all its information. So first up, we have the word bank. You can just think of this as a big shopping list. It's a simple list of all the possible words the game can pick from. The game reads from this list to start a new round, but it never, ever changes it. All right, now this next one is really the heart of the game's memory, current game state. This thing is a dictionary, and it's like a folder that keeps track of everything happening in the game right now. You know, the secret word, how many lives you have left, all the letters you've guessed, it's all in there. And if we peek inside that folder, you can see how it's organized. It uses these keys, secret word, lives, and guessed letters, kind of like labels on different sections. And this is so important. This dictionary is the single source of truth for the entire game. If you want to know what's happening, you look here. Everything else depends on this. Okay, so that's the memory. But who actually does anything? Well, that's where our workers come in. In our code, these are the functions. Each one is a specialist with one and only one very specific job. Meet our first worker, Start Game. Its job is super simple. Set up a new game. That's it. It just grabs a random word from the word bank, then it gets the game's memory ready by setting the lives to 6 and wiping the guest list clean. And then we've got Play Turn. This worker's whole world revolves around processing one guess from the player. It takes the letter you typed, adds it to the list of guessed letters in memory, and then checks if it's in the secret word. If it's not, it subtracts a life. See what's happening? It's constantly talking to and updating that central memory. And our third worker is Check Game Over. Think of this one as the scorekeeper and the announcer. First, it has to show the player what's going on. So it looks at the memory, at the secret word and the guessed letters, and it builds that familiar display string. You know, the letters and underscores, P_THN, that kind of thing. But then it does something even more important. It makes the big call. Has the player run out of lives? It checks the memory. If lives are at 0, boom, game over. Or are there any underscores left in that word? If not, then hey, you've won. This is the worker that decides if you win or lose. Okay, so we've got memory for the info and workers to do the jobs. But who's in charge? Who tells the workers what to do and when to do it? Well, that brings us to our final piece of the puzzle, the conductor. And in our Python script, the conductor is actually a while loop. This is the engine of the whole game. It's really simple. As long as this one variable, game running, is true, the loop just keeps on going, turn after turn after turn. It's literally the heartbeat of the application. And this conductor has a very specific rhythm. On every single turn, it does the same thing in the same order. 1. Ask the player for a letter. 2. Hand that letter over to the play turn worker. 3. Call the check game over worker to see what happened. It's like a real conductor, making sure each part of the orchestra plays at exactly the right time. Okay, now for the aha moment. Let's really put this all together.
We're going to trace what happens during a single guess, so you can see exactly how the conductor, the workers, and the memory all dance together. So let's say the player guesses the letter P. The very first thing that happens is our conductor, that while loop, grabs that input. Now, the conductor is smart. It doesn't try to figure out what to do with the P itself. That's not its job. Its job is to delegate, so it immediately hands that letter over to the right specialist, the play turn worker. And here's the key part. The play turn worker gets the letter, and what does it do? It writes it directly into the guest's letters list, right there in the system's memory. And that's it. That's the whole loop right there. The conductor tells a worker what to do, and the worker updates the central memory. It's clean, it's predictable, and it works so well because every single piece knows its role. So, why did we go through all of this? What's the point? It's because when you understand this structure, the memory, the workers, the conductor, the code stops being a mystery. It becomes predictable. It becomes something you can actually change without breaking everything. You now have the blueprint, which means you're ready to be the engineer. So here's your first task. There's a bug in the game. Right now, if you guess the same wrong letter twice, like X and then X again, you lose a life both times. That's not really fair, is it? So we need to fix it. We need to add a check so that if you've already guessed a letter, the game just ignores it. And that brings us to the final question for you. Based on the blueprint we just laid out, where does the code for that fix go? Which worker function is the one responsible for handling a player's guess? Think about our model: memory, workers, conductor. You know the different jobs. So, where's the right place? Now you have the map. It's time to start building.